Good afternoon, or morning, whichever it is that you happen to be watching this. Topic, derivatives of the trig function. So we've done everything algebraically so far. Now we're bringing the trigonometry in, and then we'll keep them together forever as long as we both shall live. So first thing we want to talk about, what's the derivative of sine? I've given you the answer. It's the cosine. Here's sort of why. If I look right here, when x is equal to 0, my slope is about 1. When I look here at x equals pi over 2, my slope, my tangent line, is about 0. When I look over here at pi, I'm at negative 1. So I'm about there. Okay, at this particular moment, I'm back at 0, and then I end with a slope of about 1. So if I drew that in with all the nice gradations, I would get a nice looking curve that looks an awful lot, well, not like that, but like this one over here. Looks like the cosine curve. So the derivative of the sine is the cosine. The derivative of the cosine is the negative sine. You just have to take my word, but you could go through there. It starts at 0 and then it goes down to 1, so it's working the opposite way of the cosine, of the sine curve, the slope. So derivative of sine is cosine, derivative of cosine is negative sine. Let's work from there. So if I tell you that y is equal to 3 sine x, then y primed is equal to 3 cosine x. If I tell you that y is equal to 2 cosine x minus sine x, and I want to find dy dx, which is just the derivative, dy dx, derivative of cosine is negative sine, so I'm going to have negative 2 sine x. Derivative of sine is cosine minus cosine x. Boom, boom. If I tell you that my function is x squared plus 3 cosine x minus sine x, then I want to find f primed. Well, f primed, derivative of x squared is still 2x. That has not changed. The derivative of 3 cosine x is negative 3 sine x, and the derivative of sine x is cosine x, so we've got minus cosine x because of the negative sign. So it's just another rule, 2 more rules actually. So we've got the product rule. So we've got the power rule, the product rule, the quotient rule, and now we have the rule for derivative of sine and cosine. What more could there be? There could be all of these. So we have all of these derivatives of trig functions. Every one of them has a derivative, and we want to get so that we really know them, so that we're not spending our time trying to think of what they might be. So the derivative of sine, as we said, is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared of x. The derivative of cosecant is negative cosecant x cotangent x. Okay, the derivative of secant x is secant x tan x. And the derivative finally of cotangent of x is negative cosecant squared x. And there are some patterns that you might notice. You might notice that all the cofunctions have negative derivatives. You might notice that the ones that sort of seem alike, cosecant and secant, have similar form, and tangent and cotangent have a similar form. You should be able to memorize those. You memorize the lyrics to songs, whole scenes in movies, so asking you to memorize these 6 formulas on top of the product rule, the quotient rule, and the power rule should not be a big chore for you. Good. So let's use that. If we want to know the derivative of y equals x plus secant x, so y equals x plus secant x, I want to know y prime. Derivative of x is 1. Derivative of secant is secant x tan x. And it's important that we put an argument, which is what we're taking the sine, cosine, tangent, secant, cosecant, cotangent of, after every one of these things. So we don't want just secant tan. There's no such thing as a secant tan. Sectant, no good. Secant x, tan x, and there's the derivative. If I've got this one, y equals x tan x, oh my gosh, what could that be? There's a hint. It's a product, so we got to use the product rule. Okay, and the product is, it doesn't look like it so much, but if I had written it like this, you'd all go, oh yeah, that's a product. So it's a product, so we just use the product rule, y primed, the first, times the derivative of the second. Derivative of tangent is secant squared x, plus the second, tan x, times the derivative of the first, and in this case that's 1, so I'm not going to write a 1 in there because as I do with disappearing ink, I get the disappearing ink, plus 1 tangent of x. Okay, so That's what's going on there. So the final ultimate answer is x secant squared x plus tan x. That's what my derivative of that particular thing is. So the product rule is still a factor. And I remember on the at some point I said, that we could always simplify them, but sometimes you can't. So, if we have something like 3x squared plus 5x times 2x minus 5, we could do the product rule. We could multiply it first and then use our power rule. But in this case, there's no way to simplify this, so we must use the product rule. Y primed. So first, times the derivative of the second, derivative of cosine, negative sine, plus the second, which is the cosine of x, times the derivative of the first, which is 15x squared. Then we want to make it look all nice, and there's a couple things we do to make things look nice as we go through. We never have it like a dangling negative sign in the middle, so we bring that right up front. Negative 5x cubed sine x. We also like to have our algebra come before our trig, so that we have 15x squared cosine x. We don't want someone to come along and think this is the cosine of 15x cubed because they multiply x by 15x squared, so we bring our algebra to the front. Algebra goes to the front, and then follow that up with your trig stuff, sort of like the alphabet. No dangling negatives. So if you got a negative in the middle someplace, put it in there because we don't want someone to come along later and go, oh, 5x cubed minus sine x. That's not what we're doing, okay? Negative. So tangent of x. Well, we already know the derivative of tangent of x is secant squared x. So we also might remember that it's equal to the sine divided by the cosine. And so we could use the quotient rule to figure out what the derivative of tangent is, just to make sure that it really is secant squared x. So, and to make sure that it all works out. So we go ho, d high, the derivative of sine is cosine, minus high, d ho, and the derivative of cosine is negative sine, over ho ho, which is cosine squared. Okay? So cosine times cosine is cosine squared of x. And we tend to write the squared there so it doesn't get confused with cosine of x squared. And then we've got minus and minus, so we've got plus sine squared x all over cosine squared x. Anyone remember what cosine squared plus sine squared is equal to? I heard it. Say it louder. Yeah, it's 1. Sine squared plus cosine squared is 1. And so I have 1 over the cosine squared. Anyone remember how cosine is related to secant? It's on your trig card. Okay, cosine related to secant. So 1 over the cosine is equal to the secant. So would it seem reasonable that 1 over the cosine squared is equal to the secant squared? Lo and behold, we have it. Okay, so we would never have to do that again. We just have to remember that the derivative of tangent is secant squared. One of those 8 or 10 things I want you to use. Here's a quotient rule. Again, another one we've got to just go right at it. So y primed equals ho d high. So ho is 6x squared. D high, derivative of secant. Secant x tan x. Ho d high minus high d ho. Going fast, but it's Friday afternoon for me. For you, it's whatever day it is. Squared. Ho d high minus high d ho over ho ho. There it is. We want to clean it up a little bit. And the cleaning up, we can't do a whole lot. We can't distribute this anywhere. So again, I would just go 6x squared plus 7 in parentheses, secant x tan x. Without the parentheses, the only thing we're multiplying by secant x tan x is the 7, so we need the parentheses there. Minus, get the algebra out in the front. All over 6x squared plus 7 squared. Okay? So there's that, and that's about as simple as we can make it. We could do some work further on figuring out when this is equal to 0 and things like that, but right now we're just working our way through with using our trig functions and the rules that we know about to try to make some sense of all this stuff here. That's the end. That's the blank page. So just going back to there. We got to know these. I already know them. You've got to know them. What's this little guy saying? He's saying something. Wait, what's he saying? Could be hilarious. Could be hilarious. What's he saying? Maybe we should make him really big. You still can't see what he's saying. Oh, yes. Okay, you must internalize these rules. You must, you must, you must. That's a little monkey saying. You must. You got to get these so that we know them off the top of our head. I'm rambling on, and I will stop right now with your favorite pen of all times, the... Where'd it go? Smiley face pen. See you next time. Thanks for watching. Hope you learned something. Have a good day, and all of that stuff. Ta-ta for now.